Hello friends, welcome to EPG Pathshala. I am Professor S.P. Singh from Faculty of Management Studies, Gurukul Kangdi University, Haridwar. Today we are going to study Module 12 on bivariate analysis. After studying this module, you shall be able to know the basics of bivariate analysis, understand the cross tabulation, comprehend the Spearman's rank correlation coefficient, and understand the correlation coefficient. Bivariate analysis, one of the simplest forms of quantitative analysis, examines the relationship between two variables for the purpose of determining the empirical relationship between them. It can be useful in testing simple hypotheses of association and can help determine the extent to which it becomes simpler to know and predict a value for one variable if we know the value of the other variable. Bivariate analysis. There are three types of measures used for carrying out bivariate analysis. These are cross tabulation, Spearman's rank correlation coefficient, and Pearson's linear correlation coefficient. Cross tabulation. For the purposes of cross tabulation, responses to two questions are joined and data is tabulated together. A cross tabulation compute the observations in each cross category of two variables. A frequency count for each cell in the analysis is the descriptive result of a cross tabulation. For example, in cross tabulating a two category measure of income, low and high income households, with a two category of purchase intention of a product, low and high purchase intentions, the basic result is a cross tabulation. In constructing cross classification tables, one has to first determine which data should be given primary emphasis and which should be given secondary emphasis. Data with primary emphasis are normally given in columns, while those with secondary emphasis are shown in rows. This order is repeated for higher order tables, those having three or more dimensions. This convention is almost invariably followed because it is easier to see data when figure follows one another in a column rather than in a row. The results of cross tabulation show the number of sample respondents with low income having low purchase intention, low income with high purchase intention, high income with low purchase intention, and high income with high purchase intention. The results of a cross tabulation are more meaningful if cell frequencies are computed as percentages. The basis for calculating category percentages depends upon the measure of relationship between the variables. One of the variables can be treated as independent variable and the other as dependent variable. In this case, the purchase intention could be treated as dependent variable and income as independent variable. The general practice is to cast percentages in the direction of independent variable across the dependent variable. Thus, any two variables, each having certain categories, can be cross tabulated. The interpretation of the cross tabulation results may show a high association between the two variables. That does not mean one of them, the independent variable, is the cause of the other variable, the dependent variable. Causality between the two variables is more often assumptions made by the researcher based on his experience or expectations. Just because there is high association between two variables, it does not imply a cause and effect relationship. Once the relationship between the two variables has been established, the researcher may introduce a third variable into the analysis to elaborate and refine the initial observed relationship between two variables. The main question being asked is whether the interpretation of the relationship is modified with the introduction of a third variable. There would be various possibilities of introducing the third variable. It may refine the association that was observed originally between two variables. By introducing the third variable, it may be found that there was no association between initial variables or the original association was spurious. Introducing a third variable may indicate association between original two variables, although no association was observed originally. Introduction of the third variable may not show any change in the initial association between two variables. One of the non-parametric tests used to measure the degree of association between two variables is Spearman's rank correlation coefficient. Since it was developed by Spearman, thus it is known as the Spearman rank correlation. Spearman rank correlation test makes no assumption about the distribution of the data and is the appropriate correlation analysis if the variables are measured on an ordinal scale. Sometimes we come across statistical series that are ranked according to size. This is because the exact magnitude of individual items in the series cannot be ascertained. In such case, Karl-Pearsonian coefficient of correlation cannot be calculated. Instead, Spearman's rank correlation is used. This method is based on the ranks of the observation rather than on a specific distribution of x and y variables. There are two types of problems in rank correlation. One, when actual ranks are given, and second, when ranks are not given. Spearman's R is a distribution-free or non-parametric measure of correlation. This is due to the fact that no strict assumptions are made regarding the underlying distribution from which the sample observations have been taken. As such, the result may not be as dependable as in the case of ordinary correlation where the distribution is known. A commonly used measure of association between two numerical variables is the correlation analysis. When we are dealing with two variables, we are talking in terms of simple correlation, and when more than two variables are involved, the subject matter of interest is called multiple correlations. Correlation analysis helps us in determining the degree of relationship between two variables. It does not determine cause and effect relationship. Even a high degree of correlation does not indicate a relation of cause and effect existing between the variables. By itself, it establishes only covariance. There are various methods of ascertaining correlation between two variables. These are scatter diagram, graphic method, Karl-Pearson's correlation analysis, concurrent deviation method, and least squares method. Correlation analysis. A commonly used measure of association between two numerical variables is the correlation analysis. When we are dealing with two variables, we are talking in terms of simple correlation, and when more than two variables are involved, subject matter of interest is called multiple correlation. Correlation analysis helps in determining the degree of relationship between two variables. It does not determine cause and effect relationship. Even a high degree of correlation does not indicate a relation of cause and effect existing between the variables. By itself, it establishes only covariance. There are various methods of ascertaining correlation between two variables. Scatter diagram. Scatter diagram method of ascertaining correlation between two variables is to prepare a dot chart. The data are plotted on a graph paper in the form of dots. By looking at the scatter, the investigator can make about the relationship between the variables. In graphic method, the individual values of the two variables are plotted on the graph paper. The two curves are obtained, one for x variable and another for y variable. The examination of the direction and nearness of the two curves can indicate whether the two variables are related. The direction and strength of the linear association between two numerical paired variables is measured by the coefficient r. The movement of the two variables in the same direction tells about the positive correlation between the two variables. When two variables move in the opposite direction, the correlation is negative. When the variables move in no connection with each other, there is zero correlation. Friends, in this module, you have studied the basics of bivariate analysis, the cross tabulation, the Spearman's rank correlation coefficient, and the correlation coefficient. Thanks for visiting EPG Pathshala.